Let's start. Hello, everybody. Um, Yesterday we did a lot of math because I also used this model in order to show you the different concepts which you also have already seen in other lectures for analytically optimize a problem with some site conditions. So what we have done is the maybe for you in your eyes easiest one when we just insert everything into each other, ending up with only one function, with only a function depending on one variable, taking the derivative with respect to this variable and setting this to 0. Well, of course, this is, so to speak, the uh, um, most easiest possibility. But on the other hand, especially the conditions are quite often that complicated that you cannot solve everything so that you can end up to insert everything in every formula. So the quite then general concept is this method of Lagrangian multiplier, and later on I give you also independence with the prisoner's dilemma, an optimization problem where you have not only one Lagrangian multiplier but more, because of course in general within an economic problem you have not only one condition but two, three, and so on. And what also can happen is that you have not only one target function but more target functions. So then it would be a very general, multi-dimensional problem, but in the end, the analytical way how to do it is still the same, and what you can obtain in general via this Lagrangian method is that quite often there is no analytical solution of optimization problems. But you know that there exists a solution, although you cannot calculate it. But what you can then deduce from this Lagrangian method is that you know if I change some parameters within my model from this optimization method, then I can calculate the direction. In which direction is my equilibrium or my solution moving when I'm changing one of these variables? And the last one, and this functions very well in two dimensions, is this method of calculating the total differential. And if you have only two variables two-dimensionally, then you, especially where I have it, you can calculate this derivative of the change of the one variable with respect of the change of the other variable. And for this we then ended up that in general we have talked about how does this function look like, and it is more or less just the sum of the square of our two variables. And where have I written it down here? And if you have some fixed number equals the sum of the square of two variables, then functionally or graphically this just represents a circle, or in a more general way an ellipse. And this means our indifference curve, which you know from microeconomics, is in our case just a circle. And our condition was the Phillips curve, and the Phillips curve is just a linear line of y depending on inflation pi. And then the optimal condition is, as you know from the household optimum in microeconomics, just where the two slopes, the slope of your target function, so to speak, the indifference curve in micro, the slope of the circle, the loss function in our case, coincides with the slope of our condition function. And this is, in this case, just b, and the optimal point is then where the linear line of the Phillips curve is just tangent on this circle representing total losses. Yeah, and now we go to the problem. Where do I have it? Here. Where is my reaction function? Because until now we have only talked about these discretionary solutions. And now we want to calculate also the commitment case, deception case, and discretionary case. So we now need our reaction function. And where do I have it? Up, up, up. Here it is. So then first commitment. And the second was deception, with which we have not already calculated. This was so. So, first of all, commitment means I have the announcement that pi is, what else do I need? The Phillips curve I also need, sorry. This one. Up. No. Here. Oh. Mm -hmm. So commitment I means just that PE is also 0. This means in the commitment case, I really stack to my announcement of pi to 0 and setting this into our loss function means then we obtain L of 0, and due to the Phillips curve, if pi is 0, we are setting also our total output to y star. And this would be then 1/2 times a times 0 squared plus y star minus k y star squared. This of course cancels, and we obtain 1/2 times k minus 1 squared y star squared. This would be then our overall losses. Because everybody believes each other, this is then, so to speak, the most simple case. What happens in the second case? Well, I'm announcing this pi is 0. The public believes that PE is again setting its expectations to 0, but we have this reaction function. So we have an incentive for the central bank to deviate. So this then means central bank is setting pi of pi e equals to 0. And this means here we insert a 0 and we are left with this part of a positive inflation rate now. So this is then this what we have talked about, this riding the Phillips curve. And I showed you also this outward shift over time with the US data, starting just after Second World War. And then we saw that somehow this Phillips curve, the negative dependence between unemployment and inflation, moved through the time outward. And so in the short or medium run, this Phillips curve is somehow stable, and then I just move upward. And if I surprise the public with a higher inflation rate, then I can lower unemployment, and this pushes total output. So this is the explanation of this incentive. So this would be then A over A plus B squared times K minus 1 Y star. What does this mean for overall losses? Well, we have to insert our inflation rate, A over A plus B squared times K minus 1 Y star. And we are setting again our output given our Phillips curve. So output is then given by Y star plus B. PE is 0 by assumption. Where is it? Here. So times this part here. A over A plus B squared times K minus 1 times Y star. So I think I can skip this. These two we have already done. And at this slide I calculated all this because I do not want now feed in this in the loss function. This will take about 10 minutes. So, oops, see next slide. And the last one is the discretionary case. And there we have PE equals pi. For this we have calculated in 3 possibilities. Where did I have the level? So this is B over A times K minus 1 Y star. B over A times K minus 1 Y star. And again, putting this into our loss function is then L B over A K minus 1 Y star. And now again, it is easier to calculate the equilibrium output level, since in this case the expectations of the public are rational. So they assume this increase of inflation rate, this incentive. So this part is 0, and again, this is set to potential output. And also see next slide. Okay, and yeah, to summarize all this, let's have a look how this looks graphically then. So in the first case, where everything is, or every inflation rate is set to 0, then in the Phillips curve, we have just y equals y star plus b p minus pe. This part cancels, and therefore we just obtain this long run Phillips curve, which is just a straight line. But still we have the optimal condition. So in this case, we end up just down here, and the midpoint of our circle, there we introduced at the starting point the assumption that this is a little bit higher than potential output. So this yellow then represents this case where we are very transparent, so to speak, that we really stick to our announcement that we will not increase prices. But also this horizontal line, the slope of our long run Phillips curve, just coincides with the slope of this indifference curve represented by the yellow circle. Then, in this deception case, we are surprising the public. So we are not setting pi to 0, but the public expects that inflation is 0. And this means that in this case, the Phillips curve has not this part here, b pi minus b pi e. So this blue Phillips curve is situated a little bit above the red one, the green one of the discretionary part, where this is shifted a little bit downward due to a non-zero expected inflation rate. So in this case, when the public is mis-specifying its expectations, we end up at this point here, where the slope B is coinciding with the indifference curve represented by the blue circle. And the last one, the green part we have here, when this difference here is minus b times pe, that in this case of rational expectations, then of course we have again the coincidation between the same slope but we end up with a higher inflation rate. And since the radius of the circle is representing the losses, then we end up that in this discretionary part, the losses have the largest amount compared to this very transparent and this deception part. But unfortunately, this short run analytically calculated possibility is not very relevant in practice, because maybe one time the public can be surprised, but not in the long run. So in general, when we assume these rational expectations, this would be our overall equilibrium. And this is then, as I said already, also an example of the prisoner's dilemma in economics, and this we have quite often. And then we can ask ourselves, how can we overcome this problem that due to rational expectations we have an outcome of larger losses. This, of course, would then mean that if in our central bank committee we have many people which mainly focus on price level stability, then of course this incentive of pushing output via the price of inflation would be lower. And yeah, this is then also called that over time the central bank builds up a reputation. And maybe somehow right now we have this problem in the United States. The Fed has built up a high reputation of being independent, because in general we can assume that the government has always an incentive to push the economy. So please lower the interest rates in order to push the economy. And if we have an independent central bank with, in general, central bankers which have a main focus on price level stability, then we can roughly overcome this time inconsistency problem. Or what we have also done in, especially after the financial crisis, where we had this very high volatility in the economic markets, is that we announce a quite strong rule-based monetary policy. So that we more or less maybe announce, well, we are following a Taylor rule. Or what we have also done is a so-called forward guidance. This was developed in the United States in the around 2015, 2016 to cool down the volatility in the markets, that the central bank really said, well, over the next 3 years, we will be in some corridor around 2 or 3% key interest rate. Or forward guidance, or a quite nice idea, but this we do not find very often in in the world, is that we also can say, if the central bankers have to sign an incentive contract, so that they really write down, well, we are measured in 1, 2, 3 years. How have we made it to focus on our target? So they announce an inflation target of 2%. And if they miss this target, let's say inflation rate is then in 2 years 3%, then they have a deviation and they have signed that they have to pay then. And especially about these incentive contracts, my PhD advisor has written many things, and also he had the idea that politicians in general should sign such an incentive contract. Because quite often before the polls, before the elections, we hear some announcement of our politicians, and after they are in power, they are doing the opposite. And there is then also the idea, well, if they have to sign a contract, so if they miss their promises, which they have done before the polls, that they maybe then have to step down. Something like this. But of course, this is then somehow where we have then the overlapping of just a pure economic view and the political case, because how should we really get it that they hold their contracts? Because they are in power, and if you are in power, you can change the rules. Remember Germany? We were the main actor who said, well, we want to have these strong fiscal rules within the monetary union, European Monetary Union. And then the European Monetary Union started in 1999. And we were just, together with France and Greece, the first three countries which have broken these rules. And what we have done then? Well, we were the most powerful country in the European Monetary Union. We just said we will not be punished because we changed the rules, which we have introduced in the midst of the 1990s. So maybe a nice idea, but if it really can work in practice, there we have to make a question mark. And also, if we would go further, in our model right now, we have only a 2 period model. We are starting today, and then we are changing for the next period. And to have a more relevant model, we have also to increase the time perspective. And this would then mean that we again, these should be squares. Again, we have our introduced loss function, but now we have an infinitely time horizon. And then what we quite often do, if we have an infinite time horizon, then we discount future losses here with some discount rate rho. And if we have, and this is then something like the time preference. And if this is a low number, then this discount factor here is roughly in the neighborhood of 1. So we have not a very large discounting effect in our view. And this also would then mean that then the incentive to have a reputation would be quite low because we were focusing only on today. And in the end, to be then very general, of course, over time, always happens something, especially if we look at the last 15 years. We have these 3 very large crises, and then, of course, also research shows that this general argument that reputation is good, this is then a little bit ambiguous. Oh, hard word. Because we can then also think, well, if every 5 or 10 years, like it was during the last 15 years, really the framework changes, then of course also we have to change our setup of monetary policy. Because this argumentation for reputation in general is, of course, a very long run argument. And if during this long term time, always really, the circumstances are changing, then of course we have to adjust our monetary policy or our policy in general. And yeah, I did also quite a lot, or one main chapter of my PhD thesis is especially about this Barrow-Gordon model, and I analyzed some transparency aspects within my thesis. Maybe you sometimes can have a look at it, that somebody is reading a PhD thesis. There are not so many people reading them. And then I found by Alan Blyder, he is also a quite famous economist, especially in monetary policy. He has written, maybe a quite funny paper where he also said there is a time inconsistency problem. And here, and you can click on this. Here, he made the following setup. Well, the examinations are quite stressful for you and also for me or for us, because we have to correct them. But of course, we want that you really, learn what we have introduced to you. And then he said, well, maybe it's enough to make the announcement that there will be an exam. Because if I announce it, then you start learning because you want to pass it. So you learn. And then we meet in 2 weeks or 3 weeks. And then I surprise you and just say, well, there is no exam. And then we are both better off. Because you have learned and I have no work for the correction. But then, of course, we can assume that you adapt your expectations. That you are learning, and in the next time, although I have announced that there will be an exam, you assume there will be no exam. And if you then assume that there is no exam, of course, you don't learn. And then we are worse off because we have no innovation in our country anymore. And you can have a look at it. I think it is a quite nice example where he also went through all this argumentation that this is then also an time inconsistency problem. In the central bank, it was announcing zero, but I have this expectation, or I have the incentive to deviate, and then the public is learning, having rational expectations. They don't believe me that I set the inflation rate to zero. So what else? Some guys of you have already participated in the trade lecture, and there we had it also. That we said, well, in general, we know that in a free trade case, everybody is better off. But on the other hand, and maybe this is then the argumentation of our funny guy, of Mr. Trump. Well, what is he always talking about? He says, well, introducing tariffs means that I have an additional income. And remember, I think 2 weeks ago, he said, well, due to our higher income, because of the tariffs I have introduced, I repay the public, every person in the United States, I don't know, by something like 1,000 US dollars. But this situation would only increase the overall welfare in the United States if it's still possible to have free market entrance to all other countries. Because then, compared to the free trade situation, I can sell my products to the other country, and additionally, I have the income from the tariffs. But on the other hand, of course, the other country is worse off because the other market is somehow closed. And if then the situation, we look at a symmetric situation, if the countries are more or less as both in a similar way powerful, and there especially we can have a look at the United States and China, that we there have seen then that they both directly in parallel increased their tariffs. During summer, they had tariffs both on both sides of more than 100%. Now later on, they decreased them again, but for some months, they really closed their markets for each other. And in this case, if there is no free trade anymore, then both sides are losing. And the bad thing in this case is that being rational, both have an incentive to close their markets. And so also this prisoner's dilemma is then something how we can explain the situation which we have today in the world markets. And where do we find it also? I don't think that you have talked about this. We have it also in the case of providing public goods. I think you have talked about the property of a public good. A public good has the property that it can directly used of not only one guy, but many persons simultaneously. So you are using simultaneously this room. So everybody gets simultaneously a utility from sitting here, hopefully. And then it is asked, well, how should I finance this? In a private market, we just say, well, you have to pay for it. But this is a public room, so everybody has the right to sit here. I'm not able to just close the door. Every student of our university has the right to sit here. And then I just ask, well, we have to finance, we have to build this building, we have to pay for the chairs and the tables. And then I just ask you, please pay 2, 3, or 4 euros for every lecture. And then being rational, you just say, well, I can use this room anyway. Why should I pay? And this incentive, using this room, because you obtain utility for this room, but you can use it without paying, has everybody. And if everybody is not paying for this room will not be built. And this is then also a prisoner's dilemma. How should I finance public goods? And this was done in an analytical way in the 1950s by Paul Samuelson. This is the so-called Paul Samuelson condition, that in private markets or for private goods, in micro you have derived that the marginal rate of substitution is equal to the marginal cost. Oh, sorry, this is German. So marginal rate of substitution A plus marginal rate of substitution B equals marginal cost. So here, for every single individual marginal rate of substitution, your demand is equal to marginal costs. Marginal costs is just your supply function. So this was your demand function, and this was your supply function. But when you have bought a private good, then you own it, and you can say nobody else can use it. If you own this room, you can say nobody else can enter this room. And for public goods, you have the condition that all these marginal rates of substitution add up to the overall marginal cost. And then you have the so-called free rider problem. And this is also a prisoner's dilemma. And maybe this we have in Germany because over the last 15 years, we have not invested in our public goods. Think of the economic performance overall between 2010 and 2020. This was quite good. We had a very good performance of the labor market. So the incomes, the individual incomes has increased during this time. But we have not invested in infrastructure, digitalization, and so on. Although we had the money, we have had the money during this time. And the last one, where we also find this prisoner's dilemma, I don't know, have you done this oligopolo, the Cournot oligopole in microeconomics? Yeah. And there you say, well, you have an aggregated demand function. So this X, total demand, is the sum of both quantities of two competing enterprises. And the two competing enterprises, they have individual profit functions. This is just revenue minus costs. And then you have, of course, that you are maximizing your individual profits. But into your profit function, you have to insert the aggregated demand function. So from individual maximization, you obtain a reaction function because you have to make an assumption how much is your competitor producing. Otherwise, you cannot calculate your profits. And this means your optimal output is depending on the given output of the other firm. And here you say, well, I have a symmetric problem that the other competitor is doing the same. He is also calculating his reaction depending on the other individual, on the other enterprise, so x2 of x1. And then, similar as we had it here in this diagram, where you have the reaction function cutting the equilibrium condition. We can also interpret this as the reaction function of the public. Rational expectations is, my expectation is the same inflation rate which the central banks sets. That if we assume linear costs here and also a linear demand function, then also we can show that the reaction functions are linear. I don't know if you have done an example, maybe in microeconomics, that we have falling reaction functions given the quantity of the other competitor, and that then again the cut of the two reaction functions is also the equilibrium. And if you then calculate the individual profits, then you see that if these two firms compete with each other, that then their profits, their individual profits, will be lower compared to the case that at the first step they coordinate, then use together the market power in a monopoly, obtaining an aggregated profit and afterwards divide it. And then you can show that the overall monopoly profits are larger than the sum of the single individual profits in the oligopoly. But also in this case, by rational expectations, both competitors have the incentive to react due to their reaction function, because we just individually maximize our profits. And this then means also that these two competitors in the end are worse off compared to the case that they're in the first step coordinate. Yeah, and maybe or not maybe. Also, a similar problem is with respect to climate change. Well, if we see, well, the costs of climate change are quite large in the future. And then we ask ourselves, should we in Germany reduce our CO2 emissions? But if only we reduce the CO2 emissions, nothing changes on a global level. But as we have it right now in our country, we have much higher energy costs for production than other countries, especially in the United States. So we are, because of this, um, yeah, rules for reducing CO2 emissions in Germany, on a global scale, we are less competitive. So somehow we have an incentive to step back. And this is then also a prisoner's dilemma. And somehow, yeah, to overcome this problem only in an economic way, I don't see really how this should work. And there, then we have to move to a political concept that somehow, yeah, we coordinate each other. And this was the Nobel Prize 3 years ago. Mr. Nordhaus, and he had this concept of climate club, that we stick together, some powerful countries, and then we say we form a trade union that everybody who wants to yeah, to export products into this trade union, then you also have to reduce your CO2 emissions. But this is not easy, and in these times which we have right now, maybe we have some other important problems, especially looking in into to the United States, China, and of course to Russia. So this prisoner's dilemma, or also this time inconsistency problem, we find very often, and especially in the times we have right now. Okay, so then we are done today, and next week we want to talk about economic growth, and also, but for this I have not time today. I also wanted to show you how we can solve all these yeah, problem here just by one click, feeding in this into ChatGPT. I think I will prepare this for next week, and then I show it to you, because it's a very helpful tool, but you will then also see that you know what you are doing. Okay, so thank you very much for today.